So some examples of questions you might get. The sum of the first 4 terms in a GP is 200. I'm going to write down what I know as I find it out. The sum to 4 terms is 200. Find the terms if the ratio is 3. So we want to find all 4 terms. R equals 3. We don't know A. But what we do know is we've got a formula that we can use. Now the ratio is greater than 1, so I'm going to use the version of the formula that has the ratio part first. And it's handy just to write this out. Write it out every time. It's on your formula sheet, so you can always look it up. But if you write it out at the start of each question, after a while you'll know it, and that's much faster than looking it up. So now I can sub in what I know. I don't know A, but I do know R, and I do know what the sum to 4 terms is. So I know that we're going to let N be 4. So I can say 200, because that's the sum to 4 terms, is A times 3 to the power of 4, because I'm letting N be 4, minus 1, over 3 minus 1, well that's 2. So now I can say, let's multiply both sides by 2, and I've got 400. Now I can just deal with the top. 3 to the power of 4 is 81. You can do that in your calculator. 81 minus 1 is 80. So I've got 80A on the top here. So that means that A must be 5. All right, now that I've got A equals 5 and R equals 3, I can find any term I like. So the first term is 5, that's A. The second term, I need to multiply it by 3. Now you can write it out like this, second term, third term, fourth term, or you could write, therefore, the terms are, and actually just cut straight to the answer, 5, you can tell that's the first one, times by 3, times that by 3, and times that by 3. Now in a lot of these questions, you can be sure they're right before you hand them in. Just add these up and double check that they really do add to 200, and they do, so I'm good. Now in this next example, we're given the GP, 2 plus 6 plus 18 plus, and it goes on forever. We've got 2 things to do. Find a formula for the sum to n terms, and how many terms are needed for the sum to exceed 1 million. Actually, I think that question is meant to say 1 billion. Let's do 1 billion. All right, so a formula for this sum to n terms, we'll write out the basic form of the formula. Now, we can see what the rate is here. We're going up by 3s. So quick inspection finds that out. Remember, you can also do 18 divided by 6 and check that it's the same as 6 divided by 2, which it is. So because I've got a ratio that's greater than 1, I'm using this version of the formula because it's going to work out more neatly. So that means the sum to n terms is, now I can put in my ratio of 3 so that I've got that. Do I know what the first term is? Yep, it's 2. So I know that A is 2 and R is 3. I don't know N because that's the thing that needs to remain a variable. And then on the bottom I've got 3 minus 1, which is 2. Now you don't want to leave it like that, always tidy up. I can see that these can cancel. So the sum to n terms is 3 to the power of n minus 1. That's the first part done. Okay, now for the second part, how many terms are needed for the sum to exceed 1 billion? All right, well I've got a formula for the sum. So I just need to know what n's going to be for this whole thing to be greater than 1 billion. So I can write this out, but I'm not going to write this version of it. I'm going to write the version that I have specifically for this question. The sum to n terms for this one is 3 to the power of n minus 1, and I need that to be greater than 1 billion. Now, a couple of ways to solve this. First step, obviously, get it simplified. So let's add 1 to both sides. Now, what I think is the easiest and best way to do this, take the log of both sides. That means on this side, let's do log, you can make sure they're both base e or both base 10, doesn't matter. Let's do base e. Now here, I've just literally rewritten both sides with log base e at the front. Okay, now the power law tells me that this n can float down to the front here. So rather than rewrite the whole thing, I'm actually going to write it like that. I've done 2 things in one step. Now to get the n by itself, I just divide both sides by this, the log base e of 3. So n has to be greater than this. Lots of zeros to write, over log base e of 3. So putting this then into your calculator, I get 18.8. So if n has to be bigger than that, then n must be 19. Now, check what the question actually asked. It said how many terms? So you should finish by saying there are 19 terms needed. And that way you've answered the question. Now, some people get mixed up taking the log of each side here. You could solve it at this point saying it's equal to. So your working could be to rewrite this as a log and say 3 to the power of n is equal to, and then you've got your big number here with an equals sign. Now, sorry, that's a little bit small to read, equals n. Then you could solve that. Obviously n is equal to, you've got the same thing to put in your calculator here with the change of base rule as this. So you're going to get n equals 18.8. Then you'd have to think, well, this is getting bigger all the time. So 18.8 would give me something bigger than a billion, but obviously n has to be a whole number, so it's going to have to be bigger than that to be more than a billion, so you could reason that n would have to be one more. Some people prefer this because they get a bit mixed up dealing with these sorts of things, and that's fair enough, because when you divide by the log, this part here, because 3 is a nice big number, bigger than 1, this is a positive number, so dividing both sides by it is fine, no problem. But if you've got a fraction here in this part, in a different type of question, then when you divide both sides by this is actually a negative, and that would flip the sign, and that can confuse some people. So this strategy is not silly. Solve it equal to and then think, do I need a number that's bigger than that or smaller? But as long as you're careful, this strategy is good too. Just watch out for numbers here that are smaller than 1.